Therefore, we needed to promote the passive house standard in some ways. And we made a lot of brainstormings, among partners and so on. And in the end, we decided to do two things. The first was this transportable passive house module, which I showed you before this morning, which traveled a lot in order to show how the passive house works. And the other one was, why don't we get some building which can be inhabited in order to test passive house? Okay, let's do an hotel, for example. And we convinced the guy to build up a new hotel in 2012, which is like crazy, because of course only a crazy man could invest so much money in a new hotel, without renovating the existing ones. And there's another one. He has another one, almost at the same latitude, which is Madonna di Campiglio. It is a very nice location near to the Alps, and there people go skiing. So of course it's not in front of a lake, so it's not that mild as a climate, but still comparable, because it's still in the same region. And this guy told us, okay, I don't know what you promise us, but I'm paying €1,500 a month for the other hotel. Okay. I thought 5 minutes, I thought, I already began. Okay, 15. And this guy, we told, okay, let's do something better. Let's do an economical analysis in order to see whether this hotel could be convenient or not. So we're not speaking about anything but about numbers, about costs. And of course, this should have been economically feasible for him. So among others, as said, we do courses and so on. You know this, so our third national conference will be in March. And this was the list of the existing certification units which are in Italy. Among others, also some nice non-residential ones, including kindergarten, elderly home, and so on, municipality, and this hotel. And these are the owners of the hotel, which were given the plaque, the Passive House plaque, during the last International Passive House Days. I don't know, I say something again, because I don't know if everybody was here this morning. So let's analyze this project. So this is a wooden structure. So first of all, I don't want to present this because it's a wooden structure. I'm a building physicist, and I know how important is the thermal mass, the thermal capacity of a building. We can do whatever we like with passive house, because we can build up in concrete, in bricks, in wood, in timber frame, or massive timber, and so on. This is massive timber. I really insist on this subject of the thermal mass, because if you are going to build here, you have to be conscious on all pros and contras of what you do. Because, for example, if you use a light structure, then you have to have a very good building services, because otherwise in summer you will suffer overheating. So it is. This is physics. I'm sorry, but so it is. But still, it can work, and it can reach the requirements for a passive house, even in summer. So there's no problem about this. I was just only to tell this. So since this is the one, and up to now the only one in Italy, even though we have some others who intend to build up an hotel, maybe near Rimini, so Adriatic Sea and so on. Let's see. I will present it as it is. So this is a southern east facade, and of course due to the poor orientation, because it had to be a little bit switched and not directly facing south, we had to provide also some vertical blinds in order to guarantee absence of overheating. So not only through the overhangs and all these little walls, besides we could guarantee absence of overheating. So this is worked like this. And as soon as the guys inside the rooms leave the room, and maybe they forgot to leave the blinds down, they go automatically down in order that this prevent overheating when the client comes back in the room. This is a Passivhaus hotel, which means in principle one could think about, but then the people are forced to live in like in a Passivhaus, which means you cannot open the windows, which is not true, but of course there are prejudices and so on. The temperature cannot be set as they want, but only 20 degrees, but maybe someone want it a bit colder, someone a bit warmer, no problem. We did it like it is. So everyone can choose whatever he likes. There are only some automatic controls in order to prevent discomfort, such as, for example, automatic going down of the blinds when the client goes out and so on. So where it is here, beautiful place. This is Nago-Torbole by the Garda Lake. This is also called La Busa in Italian, which means the hollow, the hole somehow, which means, as you see, it's surrounded by mountains, but here there's a sort of heat island. So here you have some more milder climate. And the hotels, this is the design concept. Here is the reception, here is for breakfast. There are 20 rooms, almost 500 square meters on 3 floors. And here at this floor, these are rooms for handicapped people, people with disabilities for motion, so at the ground floor. And at higher floors, you see afterwards, this is the basement. This is, for example, for the bikes, because Garda Lake is very well known for climbing and biking and hiking and whatever is with ing, and which is very nice, but which means that during the winter there's nothing. So it's really like this. Everyone is closing their structures. This guy who built the hotel received this year so many requests from abroad, from German-speaking people mainly, or from people coming from northern countries and so on, that he was forced to open it, even though there's nothing to do, because it's raining, it's foggy, there's partly snow somewhere, but still people wanted to go there and experiment it. A lot of other hoteliers went through and experiment and how the Passivhaus is. So he received a lot of requests. So let's go to first floor. These are the rooms. As you see, there's a central corridor, which serves also for distribution of the ventilation system, as you will see. And before going further, I want to show you a little picture of these, coming back. These are the mountains which surround the buildings. Of course, in front of it, there's the sea, but this is a lot of steeper landscape. Therefore, we modeled it very clearly in order to see how is the situation like in December or in June or in August, And what about the surrounding buildings? And what about this overhang? Do they work? Do they don't work? Do we need really a vertical blind system, shading system or not? You could argue it doesn't matter. We put it there. It's a reason of cost. So if we don't need, you don't put it there. Of course, modeling, designing before, it's very important. For example, this building hasn't yet been built, but we know, okay, there are not many, there are not windows on this face, but still it could infer something also on the lateral part. So we also design it as it would have been also a building from that side. And this is how it looks like with the trajectories of the sun and so on. This is how it works in summer. So on the top, this is the technical room where the ventilation system is. Then it goes down through some installation areas, and it goes to the rooms through the corridors. And this is how it works, for example, in winter. So it works very well. It heats the ceilings in order that they can be, they have no that much thermal mass, but still they can get some solar gains and then release it during the whole day. We have to prevent also sound transfer to the other rooms, because as it is realized in timber structure, you can figure it out which is the material which is mostly used for instruments, wood. Therefore, this would have been to prevent that some sound from one room goes to the other. Therefore, there's a lot of ceiling parts or wall extra walls with mineral wool, which prevent the sound go further. And this is made by so-called X-lam, so crossed laminated timber structure, which is sort of massive timber panels, and glulam beams for the rafters and purlins and so on. The building assemblies, for example, concerning the roof, we have a lot of different structures, of course, and I don't want to go through this. You will find it then in the internet, I guess, right? So they will be distributed afterwards, so you can take a look to it. The insulation is roughly 20 centimeters mineral wool, and here is EPS with graphite, like grape or neopor or whatever, and also 16 centimeters. Of course, in this case, wooden structure help to reduce the insulation thicknesses. This is, for example, how we realized the overhang, so the balconies, which were decoupled from the substructure through, you don't see it here, but it's here. So it's a steel angular profile, which has been completely overwhelmed by insulation, thermal insulation. And this is not that tragic in the end on the annual heating demand. You see also here, for example, a hint. This is trave fredda. Here you have a room. I will come back to this. In English, you should translate it like active beam. This is the way how to heat and cool down the rooms. I will come back later to this point. This is, for example, the floor slab. So the wooden structure goes directly on the concrete basement. And here is outside, here is inside, here is cold. And of course, cold side, we made some extra insulation on top of the the ceiling below on the colder side. This is how we adapted a common, let's say, window for the installation in a passive house. We wanted to have it as cheap as possible, but still suitable for a passive house, which required a lot of calculations. It's not yet optimized in this solution. There's other solutions which I don't show it here, but where we achieve even lower values for the psi values of the installation. And in the end, we tried to work on the profile, on the holes, and so on. And we, as you see, it's become better. And these are, for example, the values. So it's not that fantastic, but still, if it's okay, it's okay. So if there's no condensation, no mold growth, and we are under 15 kilowatt hours per square meter in the year, this window costs €300 per square meters. So why not? This is the scheme of the ventilation system with heat recovery, 90%, which stays on top of the roof and which distributes along the corridors, as said. And here, these are the active beams I was referring before. So the idea is simple. We want to give the end user a regulation or of whatever temperature, of course, between a certain range. How do we achieve this in a low-cost way? So the idea was it goes directly in the room after the passive heat recovery, after the ventilation system, and then there's something active in each room. This something active are sort of chillers, if you wish, where the air flows through, and in these active beams, cold water for the summer and hot water flows directly there and heats the incoming air. In order that it works very well, through Coanda effect, it can reach long jets and still providing the thermal comfort to the occupants. This is how it works, basically. So this is provided by heat pump, which is here, and through a puffer, so a buffer, and storage for the warm domestic hot water. Everything goes from the puffer, so the storage for the system water, if you wish. It goes basically to these collectors, and then it's been distributed to each active beam. Is it clear how it works? Which is a very tricky way of doing it, but without post-heating the incoming air directly after the heat recovery system. It is done room for room. If the user is okay with the temperature, it's okay. Otherwise, it can act on it and set a different set point. So we had different issues to tackle. So occupancy values in case of user discontinuities. For example, how can we account for the internal gains, internal heat gains? This is very difficult, especially if you make a new project, a new building, especially in the non-residential buildings. In this case, we took all the average occupancy values of the area on the Garda Lake, and we tried to split it monthly. And the nice thing is that in this way, even though maybe some more or some lower value of internal heat gains could be there, still the passive house work. And this is the major result of this. The some overheating problems, this was also due to a poor orientation, and this was taken this was solved through the installation of external vertical blinds. And these were, I already said, so automatic mobile shading systems are needed in addition to fixed overhang systems. And then evaluation of costs and benefits. So as a building physicist, I have to go to the numbers. This guy told us that in the other hotels, he pays €1,500 a month for heating. In this hotel, he pays €1,500 a year for everything. So this means economically feasible. This means that he gets higher occupancy of the hotel, as I mentioned before, because people like to go there. This means a great opportunity for us to disseminate the concept of a passive house, because people can convince themselves by going there and convincing themselves that there's no prejudice, there's no, in fact, a posteriori thing that could prevent the thermal comfort in a passive house. They are free to do whatever they like. If we want to regulate the temperature, they can do it. If they want to open the windows, they can. Of course, when they go out, windows close, obviously. So our experience shows that besides enhancing tourism and comfort, this kind of building is also economically feasible. This hotel was completed in March 2013 and was certified as a pilot project together with the Passive House, by me and the Passive House Institute as a certifier. And this is what they said. Our greatest satisfaction in having built a Passive House hotel comes from our customers' smiles, happy to have had the chance to stay in a building that cares for those who inhabit it. Now that is pure energy. Besides this, they offer eco things, eco food, and all these kind of experiences, which also are also liked by the customers. So these are the last pictures. So I'm really in time, incredibly. Yeah, null plus, something 0 plus. If you see here is the 9th of August 2012. It begins with the construction of the external walls. This is the stairs, and this is for the lift, for the elevator. Then they come the rafters and purlins. It go further. Then it's closed through the wooden boards and so on. And here, as you see, the air tightness is done like this. So from the inner side, you see this. This is basically the vapor retarder, let's say, which has been left a little higher, which will be sealed with the incoming new external wall in order to realize a continuous airtight layer. So this is how it's been done. And it goes further and further, as you see here, right? And it goes further, 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 and then on the top, they have to go with some extension for hosting the ventilation system, which has to be very large. So something like 1,300 cubic meter per hour. And in the end, this is finished. And this is 11th September. 1 month, it's over. This is how it works with wood. So again, if you do something, do it well and do it for your country, for the healthness and the future of your children. Thank you very much. Ευχαριστώ.